from once again. All right, so welcome again. Good evening to all. This is a orientation program. We are Pachkaude Research Center. We are doing a cutting edge research and development in VLSI and nanotechnology. That's in the bottom. You see the website address of our research center. So brief outline of this talk today is I will provide you the course information. We'll talk about the features of this course. We'll also help you explain how you will benefit through this course when you take the course, if you take the course, what kind of material, resources, skills you will develop, and so on and so forth. I'll also give you instructor qualification and experience so that you can understand from whom you are learning this course. We'll briefly tell you about what is this course duration, what would be timing, and a little brief overview about the VLSI industry now in India and all over the world that is going on. So as the name suggests, the course name is Digital Logic Design and Verification. On the left side you see that we have a logic gates, we have flip-flops and so many other primitives that are built together, integrated together to build any digital logic IC. So on the right side, when we actually have this chip which gets fabricated, we put this chip on the PCB, which is printed circuit board, and this particular system becomes applicable in any of the electronics that we are surrounded with today. Whether it's your mobile phone, your laptop, your games, your car, and so on and so everywhere you look around, there is an integrated circuit inside a portable system. So course features would be such that in this course features the basics of HDL, which is hardware description languages, which is Verilog, VHDL and System Verilog. These are the three industry standard languages which are being used to design digital ICs. So this course will talk about HDLs, how to use them to design synthesizable digital circuit. It means when you write a code, the module will automatically generate this circuit for you. And this circuit and thousands of such logic gates, when they are integrated together, will tell you how they are used to make the system on chip, application specific integrated circuits or programmable logics. This course also will help you understand how the semiconductor ICs are fabricated, how they are designed and how they are verified. This course also features the hands-on experience with industry standard simulation softwares which are being used all over the companies in the design of digital ICs. And through this course, one can grow his or her career prospects by learning the in-demand skills that are required for today's digital IC design. So this course feature is that this course has been divided into a small length and distinct modules so that you can learn at your own pace. It's easy to help you understand topic wise, module wise and chapter wise. So this course also features the implementation of various programmable logics or circuits in field programmable gate arrays using the hardware description languages such as Verilog, VHDL and System Verilog. So there are lots of assignments, there are lots of labs, there are lots of homeworks, tutorials, there will be a test, exams, interview practice, all from the industry practical and point of view. Because we are a research center, we are providing this industry grade course. There will be arrangement of seminars from the industry networks and the connections that our research center has. We'll arrange them periodically for you all to understand the latest industry trends, and those experts will also share with you how ICs are being designed, what skills are required, and they will also share with you all their skills and knowledge required to be a IC designer in the VLSI. Projects will be assigned as per your progress in your top skill. Suppose you show you are very good or you are becoming very good in RTL coding, and you are very good in analyzing the waveforms of the digital circuits, or you are very good, becoming very good in designing various kinds of digital logics and circuits, then accordingly the complexity of the projects will be given to you, because it will ultimately only help you. What you are going to learn in this course? You are going to learn the design flow used in the VLSI industry. You see that if, for example, as a company, we receive a project from another big company to design a chip or IC for wireless communication or for optical communication. So people will teach you how to derive system specification, how to understand them, then how to design the architecture of a logic. Suppose it's a microprocessor design that you want to do. And all the steps will be taught to you, and you will learn what is circuit design, what is physical design. This is a complete chain. You will learn fundamentals and advances that is used in industry for the design of digital logic and its verification. You will learn how to build, compile, simulate and verify the basics as well as advanced digital integrated circuits or logic. That could be simple gates, that could be simple combinational or sequential circuits such as flip-flop, counters, registers, arithmetic logic units, etc. We'll also share a detailed syllabus with you all. So you see in the right side there is a code. When you actually compile it and simulate it, it generates a waveform. So you will learn how to write this code, how to understand the syntax, how then when the code generates the waveform, how to understand and analyze this waveform to verify the logic you have designed. So you will learn how to start with the functional description and how to implement a synthesizable HDL code for your complete chip design, because chip design would be consisting of thousands of logic gates and 10,000s of transistors or even more than that. So we'll understand and help you learn all these basics and advances. So as I said, you will learn how to implement combinational logic. For example, this is the circuit of a decoder circuit, 2:4 line decoder. Bottom, this is the circuit or logic for a sequentials. So this is the flip-flop logic. So we learn how you can write the code to design such and implement such logics, whether it's combinational and sequential, using the HDL, VHDL or Verilog. You will also learn how to draw the schematics and the coding style. You will learn when you design a particular logic, you have to have inputs to it. So that concept is called test bench. So you will learn how to examine the behavior of a digital logic with a stimulus. Stimulus, it could be inputs and outputs in a test bench. And you will create and simulate the HDL test bench for your digital logic given your specifications. So you will also learn when you use a particular HDL, which is hardware description language, you will learn what are the different coding styles, is behavioral or structural. For example, here is the top is the behavioral modeling style. It means inside this black box, you don't know what the logic is. You basically have only the inputs and you define the outputs. And automatically the logic gets built based on your coding. On the other hand, there is a structural modeling in the bottom. You specifically design and write a code that will implement a structure of the logic. For example, you want to build a multiplexer. Then you will decide as a designer whether I want to use and build that multiplexer using transmission gates or a simple pass gates, or you're using a transmission gate or simple transistor logic, right? So you will use the industry level coding techniques to optimize the digital design and verification, because when you have the design of your logic, you also have to optimize it for speed, power and the area, because that's why our today's digital chips are being designed. So you will learn how to use these modern modeling tools, simulation tools, synthesis tools and the verification tools. So that was all about your course details. What you are going to get through this course, you will have a magnificent knowledge and the technology know-how of VLSI industry, because we are going to give you that skills and the knowledge. There will be a coursework material and the resources that will be shared with you throughout the duration of the course, and that coursework material is the tool access, will give you the tools so that you can use it to model your codes, simulate it, synthesize it and verify your logic design. You will have access to all the PowerPoint slides, lecture notes, PDFs with numerous examples to help you solve and understand and get trained and get skilled in the digital logic design and verification. You will have a lifetime access to all the course videos for the duration of the course. We'll provide you excellent career guidance. We'll see in the moment in the next two slides what kind of career guidance that could be. Whether you want to go to industry, whether you want to go to higher education and so on. You'll also receive a certificate of completion at the end of this course. So how you are going to benefit again, just to brief and just to revise, you will build your skill sets which are required in today's VLSI industry for the logic designers. There is a job specification called as RTL designer or RTL VLSI engineer or front-end VLSI engineers. So those are all entry-level jobs that people are looking for freshers, but with the right skills and the right training and the detailed knowledge of how the chip and the logic is designed. You will become a well-trained engineer for the VLSI industry. You will be getting job ready for the VLSI industry. In case your goal is to get in the higher education university or the institutes in India, USA, UK, EU, you can develop and demonstrate at the end of this course. You can demonstrate your skills through your CV, through your online presence, on your online curriculum documents. You can show those skills, how good you are. When you apply for the universities outside abroad, they will see what kind of projects you have done, with which center, who is your instructor, who has guided you, etc. All those skills, and that will be helpful to secure top positions for the master program or so on and so forth. So who is going to teach you for this course? It's me. I'm going to tell you about my qualifications and experience. My name is Dr. Vinayak Pachkavade. I hold PhD from the University of Liège in Belgium and also MS degree from the National Tsinghua University in Taiwan. These are the two top and world recognized universities for the electronic engineering and applied science. I am also a senior member for the IEEE. I am a member of IEEE IMS. Currently, I am serving as a founding director at V. Pachkavade Research Center. From my first degree, I hold more than 20 years of experience in engineering, science, and applied technology. You can use Google and put my name there to surf. You can see my Google Scholars. You can visit my LinkedIn profiles. And here is my IEEE address that you can use to communicate with me. Of course, you also have email address for our research center. So that's my background and expertise. My expertise are in the sensors and the circuits. I have a direct tape-out experience for the analog and digital circuits with the top foundries such as TSMC and UMC. So I'll brief you now about the course duration and the timing. just understand that there is a star mark here, so it's bit flexible. We'll adjust this according to the needs of the participants and their availability and as per their convenience. So course duration is kept about 4.5 to 5.5 months, depends on your progress and how we can speed up, how we can slow down, how we can uh, be intermediate during the delivery. So this involves your lectures and the lab sessions. The timing would be evening 6:30 p.m. Uh, there'll be a 4 days a week, uh, Monday, Tuesday, Wednesday, and Thursday, 45 minutes each session, where we'll give you so much of information, laboratory practice codes. Will teach you step by step in a distinct module how you can implement a simple logic, for example logic gates. Then we'll teach you how you can implement a combinational logic, for example flip-flops. Then as you progress, we'll teach you how to use these tools to write a code, how to use these tools to have a different style of writing a code. Then we'll use and teach you how to simulate a code. Then we'll teach you how to understand the waveforms. Then we'll also teach you how you can understand the generated circuit, because the tool will generate you the circuit for that. For example, you designed a counter and you wrote a code, you simulated it, and the circuit is ready. But you need to understand how that circuit is behaving. So that is called verification. And then we'll assign you a projects also. So lab sessions as applicable would be there. So after Thursday, Friday, Saturday would be would be your lab session practice that you can use. You will have a lot of assignments, coding examples. We'll give you a lot of materials to help you. And holidays would be off.